Okay, so this time we choose a model using differences or ratios. Alright, so for problem number 2, which type of function best models the given ordered pairs here? So you don't have to graph it, you just have to look at the different ordered pairs given here. So your ordered pairs are this. You have 1, 2, 3, 4, 5 different ordered pairs. So the best way to organize this given is to write it in a table form. So you have x and your y coordinates there. So if x is -1, y is 0.5. If x is 0, y is 1. If x is 1, y is 2. If x is 2, y is 4. And if x is 3, y is 8. So you have a tabular form of these ordered pairs. Now, it's easier to use the differences or the ratio concept when it's in this form, because you can clearly see the differences between your x coordinates and your y coordinates. Okay, now, so for the differences, in getting the common difference, you consider first the given values of x that you have. Make sure that the interval is common. So say for example, between -1 and 0, the interval is just 1. The interval between 0 and 1, the interval is still the same, also 1. And the interval between 1 and 2 is also 1. And between 2 and 3 is 1. So that means you can consider now their corresponding y values. Either we consider the differences or the ratios. Okay, first, let's see if they will make a common difference here. Now, how to get a common difference here? Simply subtract the previous, the next coordinate from the previous. So in this case, it's 1 minus 0.5, which will give you 0.5. Okay, this one. And then next you have 2 minus 1, which is 1. And then you have 4 minus 2, which is 2. And then you have 8 minus 4, which is 4. So these are the differences. And clearly, the differences is not common. Okay, the differences is not a common constant or a common number. Therefore, we can't say that this function can be modeled by a linear function or a linear model, because you don't have a common difference here. The only way for a function, for a set of data to be modeled by a linear function is that if their y values have a common difference. Okay, but here you can't have that. You don't have that common difference because the difference keeps on increasing. Okay, it keeps on increasing. Okay, let's try the common ratio then. Okay, so this is how you get the common difference. Next term minus the previous term. Now, for the common ratio, let's check if the ratio is equal. Instead of subtracting, you divide it. Okay, so let's try this first. Next term divided by the previous term. You still consider your y values. You still consider your y coordinates here. So let's start with 1 divided by 0.5. 1 divided by 0.5, or 1 divided by 1/2, which is just 2. And then you have 2 divided by 1, which is just equal to 2. And then you have 4 divided by 2, which is just 2. And then 8 divided by 4, which is also equal to 2. So notice that their common ratio, their quotient is all the same, which is 2. Hence, we can say that this set of data here has a common ratio of 2. And yes, it's common because it's all the same.